Okay, Patrick, so before I dive into my data set too much, just talk about missing data, so, and just like in general, so it's any observation or information that, we intended to collect and then failed to. So it's extremely frequent, despite our best efforts, and it can bias our research, and it can exist in ways that are unexpected. So if you look at my data set, I have 34 animals, but I actually started this study with over 100. And so basically through subject attrition, a lot of them didn't even make it to the 4-month testing period. And so you can imagine that there might be a reason why some animals died and some didn't. And that reason may or may not be involved in the dependent variables that we're interested in measuring. And so obviously, they're excluded from the analysis in a way that might bias my results. So there are different types of missing data. So missing completely at random. There's no way to know like what exactly is missing, and by that I don't mean that you can't go in and find the blanks in your data set, but rather there's just no way to predict who's going to have missing data. So it really is like completely random. Missing at random is the next classification level. This is actually like not random because it includes things like logical skip patterns, but it occurs when all of the relevant variables are observed, and so we've like observed like variables that allow us to predict which subjects will have missing data. So basically MCAR and MAR are both treatable, whereas the final level, missing not at random, is not. And that's a serious problem for research because it occurs when you omit a relevant variable and you don't observe like the variable that you need to help predict missing data. So that can be particularly devastating. So prevention strategies for preventing missing data, happen at the design level. So we can come up with ways to prevent subject attrition. In humans, we can do things like increasing incentives as like the study progresses. But in my case with animals, this includes things like using a sterile environment and catering to the animal's needs to, help ensure maximum survival. We can also, change our measurement where we basically minimize people's workload, and don't ask stupid questions that we already know the answer to, like things like demographics in our sample, and we can also do things like pilot our measurements to figure out if there's problems ahead of time that might lead to missing data. And then we can also change the way that we handle data by using things like online measurements and essentially I get surveys in the mail all the time where people want my opinion about something, and I'm obviously never going to go to the post office to mail that and invest that much. Whereas if they sent me an email and just asked a few key questions, then I might actually give them the information that they need. So my specific example of missing data is again these tau values, and so basically the reason that those values are missing is that the circadian rhythm of those specific animals was so disrupted that the computer couldn't answer how often the cycle repeated itself. So basically, in the case where I find exactly what I want, I get missing data, and so that's a really huge problem. It's obviously got some kind of pattern to it, and we can't really distinguish between missing at random or missing not at random. We have to statistically persuade people. But basically, I'm not sure if I've observed, variables that can predict that. So hopefully I have, and there's hopefully other ways that I can kind of quantify that. But it's certainly not missing completely at random. And so whenever we have missing data like this, there's a variety of ways that we can go about dealing with it. One of the ways, and it's actually the way that I'm going to deal with this situation, is deletion, because this variable is really not helping me. When I find my prize data produces, missing data, that's a real problem. But the two different types of deletion we can use are listwise, where we delete an entire variable like I'm going to do, or pairwise, when we just exclude a subject from analyses where it has missing data, but include it in other analyses. And you can see for, even just by looking at, my data set, that if we did, something like that, then excluding, these animals with missing values would really completely destroy any validity of what I was talking about when I was looking at tau values and things like that. So we can also use imputation. One way to do this is mean substitution, and we'll just take the mean of a value, the sample that we're looking at, and fill it in. This homogenizes our groups and biases our results against us because we make everything look like average, and so it's hard to find differences. We can also do regression imputation, where we input a predicted value from the regression equation, and while this seems like a better idea, it biases our results in favor of us because we get data that's predicted from our model, and then we test that data set. So it's reinforced our model before we have even really established that it's valid. And one of the optional readings talked about using last observation carried forward in medical research, and it's not actually relevant to this data set, but I'm also doing Morris-Water maze testing, so that's 8 days straight of looking at learning. And so whenever you're doing longitudinal work, you're looking at a construct that is optimistically or potentially changing. Otherwise, you wouldn't be doing a longitudinal study. So it's usually a terrible idea because you just, as the reading talked about, the later values probably have little to do with what those actual values would have looked like had the subject continued to progress through the study. And then finally, probably the best method of imputation is multiple imputation, where we randomly fill in values from other subjects multiple times. So to do this, we generate multiple data sets and can compare them for reliability. And if the results change a lot based on the specific imputations of a given data set, then that's not a good thing. And it allows us to address sensitivity, and basically this method of imputation is strong because it maintains variability, and we can check it for reliability. But we could also do things like adjustment and adjust regression coefficients or other weighting procedures, but those are also generally a poor idea. So when we go to explain our results, we can, essentially at some level have to make a judgment about our data set, and basically what like I said, I'm going to do is I'm going to, list-wise delete this variable, but what I did instead was asked a different question, and did, basically based on this, did the animal have a recognizable circadian rhythm pattern, just by creating a yes or no dichotomous variable, and ironically doing that actually gives me more of the information that I want. And then when we go to report things like this, we talk about the methods that we use to prevent missing data. So in my case, things like the sterile colony, and also diagnostic information. How we identified missing data, which I imagine is maybe a bigger deal for data sets that are much larger than this, and then also like the treatment methods. So if we had to delete animals or things like that, we should report it, and then we should also report our sensitivity results before we discuss our findings.